Okay, good afternoon, everybody. My name's Charlie Nicklin, I'm Chief Exec of IAgrE, and I'd like to thank you all for joining our September presentation. I'd like to welcome Adrian Hill from Morris Lubricants for our lecture today. Adrian is an applied chemist and has been with the business for 35 years and is currently the technology manager. As the title of the lecture suggests, Adrian is going to talk to us about the role of lubricants in agricultural equipment. As usual, everybody will be muted, and if you'd like to ask questions, please pop them in the chat at the bottom of the screen, and then we'll unmute you at the end of the presentation and you can ask in person. Okay, I'll now hand over to Adrian.
Charlie, yes. So as I say, Adrian Hill, Technology Manager. So yeah, I'm sort of guide you through today's presentation. It's basically to give you a bit more background on lubricants. I mean, lubricants generally are a critical fit to most applications. So, and the ag world is no different. So just to give you some kind of features and benefits of agricultural lubricants, what we want from them, but what can happen if things go wrong as well, or incorrect choices are made. So I shall now attempt to share my screen. Some really basic chunks, really, I suppose. I'm gonna just give you a quick overview. Some of it is quite generalized because obviously, as you know, in the ag world, there's lots of weird and wonderful beasts that do lots of weird and wonderful jobs. But so there's an element of generalization, but the principles will apply. Give you some idea of the performance features of these lubricants that are used in this marketplace. Some are multi-talented, some are very specific to do certain jobs, but we'll talk through those. And then really just a little bit of a summary at the end, just to give you a flavour for, the benefits of getting it right, and perhaps a little dip into the future to see where things might be going. So in general, we have obviously various compartments on a piece of agricultural equipment. So they all have their own particular lubrication needs and demands and specialized chemistries. And it's really about getting all the chemistry, all the technology balanced correctly for each of these compartments, to make sure you're maximizing the component life, the longevity of the equipment. And the trend tends to be, we work very closely with the farming communities. Vehicles aren't replaced as quickly as they used to be for lots of economic and global reasons. People are hanging on to equipment longer. So the more you can do to protect that asset, the better. And lubrication obviously plays a vital part in that. So we'll step through each of these different compartments, and I'll give you some features and benefits of the lubricants, what they're in there for, what they're trying to achieve. But as I say, a kind of a follow-up slide to say what can happen if the incorrect lubricant is used. So we kick off with engines. I mean, engines are probably where we've seen the biggest changes over the years, and it's all based on emissions technologies. So if you look at the front end of any piece of agricultural kit these days, it's the engines which have probably the biggest changes over the years. We'll get onto transmissions in a little while because they've obviously changed as well significantly. But the emissions legislation which has been imposed, as you can see through those different dates, has impacted quite heavily on the engine hardware design and compliance with that particular piece of legislation. Where we are now is stage 5 in Europe, which has been around since 2019. So stage 5 compliance imposes certain restrictions upon what can come out from the exhaust gas stream. The Americans are just a little bit behind us with their final tier 4 not being upgraded yet to tier 5, but we believe that's on the way. So obviously, if you're running American-based vehicles like John Deere's, for example, they will be looking at a tier 5, but final tier 4 is where we are currently for North American builds. But in Europe, we are looking at stage 5 compliance. Now, this gives you a flavour for what the emissions technology has done over the years. So there's been some significant improvements in what's coming out the exhaust pipe or the exhaust stack on a diesel-powered piece of off-highway equipment. If you look at the left there, where we have the stage 1, tier 1, back in the late 1990s, if you think of those blocks as unwanted pollutants getting out into the atmosphere, you can see PM up the one side, particulate matter. So obviously, generally when we're talking diesels, that's the soot component. And then NOx gases and hydrocarbons, HC, which is unburnt fuel. So all of these things aren't particularly wanted in the atmosphere. And so back in the days of stage 1, tier 1, there was still quite a lot of nasties coming out of the exhaust pipe. As we progress through the years, as you can see, all the way now to where we are, stage 5 for European compliance, they're very clean. These engines now are very clean compared to where they used to be. And, diesel just tend to get a bad rap. But really, what's coming out of the exhaust gas stream of a modern diesel engine, particularly in this environment, but also on highway now, of course, as well, they are very clean in terms of what's coming out of the exhaust pipe. So there's been a lot of technology changes to the hardware, to the exhaust systems, from the old stage 1 all the way up to stage 5 where we are now. And these have come in various shapes and sizes over the years. Some are more recent, but I think these are all commonplace now within the agricultural market. So we have EGR. As you can see, we're referring to the kind of reduction we're looking at. So EGR is a NOx reduction process. The AdBlue system, more technically known as SCR, or selective catalytic reduction, is a NOx reduction process. Then we have particulate filters, so diesel particulate filters in this particular case to remove particulate matter. So obviously we tend to refer to soot as particulate matter. And then diesel oxidation catalysts are also now included in the mix in certain vehicle designs. They all do a role, obviously have a role. As I say diesel oxidation catalyst, sorry, I didn't mention the carbon monoxide reduction, particulate matter reduction, and hydrocarbons. They all have a role to play. Sort of modern stage 5 compliant engines will probably have all of these bolted on in some way or another. But they're all they either impact quite greatly on the way the lubricant has to perform, or the lubricant can impact quite greatly on the way these after treatment devices perform. So we tend to refer to SCR, DPFs, and diesel oxidation catalysts as after treatment devices, whereas EGR tends to be a component within the actual engine hardware itself. So EGR is basically taking spent exhaust gases via a valve, reintroducing them back into the combustion chamber with the fresh fuel and air mixture. Now, to stop NOx gases being formed, so obviously nitrogen is 80% of the air that's been sucked into the fuel system. If you burn it at high temperatures in the presence of diesel, of course, then it will want to oxidize to NOx gases, which aren't particularly nice. So the reintroduction of spent exhaust gases basically starves the nitrogen of oxygen. So less NOx gases are produced and more nitrogen makes it through back to the outside world, which is ticking the environmental box. But the problem with putting spent exhaust gases back in and starving the whole reaction of oxygen means you've got unburnt fuel. You've got an incomplete combustion reaction. Now, incomplete combustion of diesel fuel results in soot. Okay, so that's where we're getting soot from. And anybody who spent any time around an EGR engine knows they create a lot of soot, and that soot can create all sorts of havoc within the engine. Of course, the soot will get past the compression and oil control ring into the sump and be circulated around the whole of the engine. Soot isn't good. Soot's abrasive. It's an abrasive material. So if you're circulating that around to all the moving parts, you're effectively circulating a grinding paste, which isn't particularly good. The other problem with soot, it's like flour in water, if you like. It's a solid material which starts to thicken the oil. The oil has to be of a certain thickness in order to circulate and cool the hot parts of the engine. So as soon as you start to thicken the lubricant with too much soot, then basically your ability to cool can be a problem. And especially agricultural equipment, which tends to do a lot of idling, so you don't get the airflow over the radiators, then if your engine oil isn't cooling effectively, you'll get into an overheat situation, which could be potentially catastrophic. So These are two of the biggest issues we've got with EGR is soot thickening, as we refer to it, and also abrasive wear as well. Now, the other problem with putting spent exhaust gases back in is they're quite corrosive. Normally they'd be lost to the atmosphere, but anywhere where those corrosive exhaust gases make contact, such as top compression rings, valve guides, valve stems, there's the potential for corrosive attack. So you need to be able to combat that. So an oil designed around an EGR engine has to have good anti-wear performance, as the name suggests, prevent wear from taking place because of the abrasive action of soot. It has to have good dispersancy properties. A dispersant breaks up the soot so it doesn't accumulate and overly thicken the oil. And it also stops it from blocking oil ways and oil galleries, which could lead to oil starvation and engine failure. It also has to have good corrosion control, so good corrosion inhibitors in the oil film, which we can leave on those top compression rings and the valve guides and valve stems. So it's a tough environment, EGR is, and the lubricant has to be capable of that. Otherwise, severe wear normally kills an EGR engine, and normally it's the cams that go first. With SCR is basically you're introducing AdBlue, which is a urea solution, into the exhaust gas stream. And then that mixes and goes through an AdBlue catalyst or an SCR catalyst. So in there, I mean, it's the catalyst which is the key to this particular system. So we have urea, which is, if anybody ever smells AdBlue, it's the urea you can smell, which contains ammonia. The ammonia combines with the NOx gases in the SCR catalyst. There's lots of little reactive sites in there which facilitate this reaction. And you have nasty NH3 ammonia going in, combining with nasty NOx gases. And we basically get nitrogen and water vapor coming out the other end. So I like to refer to it as two nasties going in, two nices coming out the other end. So that is the way the system should operate. The catalyst, which makes all this work, is very sensitive to certain chemistry in the lubricant. So when we go all the way back up to the combustion chamber again, and we always burn a little bit of engine oil in the combustion chamber because, as I've mentioned already, you have to lubricate that top compression ring, you have to lubricate the valve guides and valve stems. So you're always incinerating a little bit of oil all the time. That process of incineration effectively breaks down all the lovely active componentry and chemistry we have in there into its component parts. And some of the chemistry is based on sulfur and phosphorus. Anti-wear chemistry, for example, certainly is. Sulfur and phosphorus atoms find their way down with the exhaust gas stream into the catalyst. And the little active sites in the catalyst matrix, which allow two products to come in and create gas, basically, or water vapor and nitrogen. So they would normally flow away and re-expose those sites so the process can continue. Then sulfur and phosphorus will actually, they also like these active sites, but they'll permanently attach themselves to it. So no more reactions can take place on those sites. And we refer to this as catalyst poisoning. So when we say catalyst poisoning, we are basically reducing the effectiveness of that catalyst by lodging atoms in place that shouldn't be in there, and so no other reactions can take place. Now, like all these systems now, you'll be fully aware there's loads of electronic control everywhere. So the emissions, the quality of the exhaust gas stream coming out through the exhaust, through the SCR catalyst will be monitored. And as soon as the ability of that system to reduce NOx gases is no longer effective, then you will get warning lights, half power, limp mode, and various other ways of notifying the operator it's time to take it to the workshop. So these things police themselves these days. So we have to make sure that the chemistry used in these engine oils provide enough protection for the engine. So in this case, enough anti-wear protection to stop wear taking place, but not too much that the expected lifetime of an SCR catalyst is reduced. Okay, they don't last forever. There is an expected service life for an AdBlue catalyst, but putting in the correct lubricant, the balanced chemistry in there, will will help it along its way to maximize its service life. DPFs are, as the name suggests, a particulate filter. So they are catching solid debris, which is generated in the combustion chamber. And as I say, in the case of diesels, of course, it's mainly soot. So these work normally. You will have a pressure differential sensor, which measures the pressure across that unit. And as it becomes blocked with soot, okay, it's a kind of a tortuous route for the exhaust gases to go through, and it catches the soot in there. As it catches the soot, the pressure differential will start to, I do apologize, will start to sense a decrease in pressure, essentially. So the pressure will start to decrease as it becomes blocked. Now, what would normally happen, sorry, I do apologize for having Teams meetings popping up. So basically, so what will happen is once the pressure differential sensor detects a drop in pressure, it will initiate a regeneration cycle. So usually a regeneration cycle involves a certain amount of unburned fuel being allowed down into the DPF. As soon as you get things flashing around 620 degrees centigrade, that's hot enough to turn the soot, which is essentially carbon, from solid to carbon dioxide, which is a gas. So we go from solid, which is blocking the filter, to a gas which flows out of the filter, therefore returning it to a normal working pressure. So that's what normally happens with a regeneration cycle. Now, in terms of getting the oil technology correct, there are certain compounds within the oil formulation which are based on metal compounds. So you've got calcium, magnesium, and zinc. Calcium tends to be associated with the detergents for cleaning the hot parts of the engine. Magnesium tends to get associated with dispersants, and zinc tends to get associated with the anti-wear chemistry that I've already mentioned. So when you incinerate that little bit of lubricant, you've also got calcium, magnesium, and zinc atoms, which form a metallic ash, which flows down into the diesel particulate filter. It's caught because they're solid. But when we go through the regeneration cycle, the soot is burnt off, but unfortunately, the metallic ash which is formed remains behind, because this was formed in thousands of degrees centigrade in the combustion chamber. So every time this goes to regenerate, unfortunately, the actual working pressure eventually will get to a point where you can't be reached anymore. So at that point, again, the sensor will say, okay, look, we're blocked. We've got too much debris in there. This needs to be replaced or regenerated or cleaned, and it will put it into half power mode, limp home mode, etc. So that we have to make sure that when we're formulating these lubricants, there's enough calcium and magnesium and zinc in there to keep things clean and disperse soot and stop things from wearing out or corroding and rusting. There's enough to look after the engine, but there's not too much that the diesel particulate filters will become prematurely blocked and replaced. I was at an AGCO college not long ago when they had a Fendt DPF unit on there to the value of £14,000. So these things aren't cheap to change. So incorrect lubricant will prematurely block a DPF. As I say, they have an expected service life. An incorrect choice of lubricant will shorten that. Excuse me. So the diesel oxidation catalyst, it's not been around as long as some of the other technologies on this slide, but it's kind of in there. It's in the exhaust gas stream in order to start clearing up the exhaust gases before we get to the AdBlue catalyst and we get to the DPF. So it's a catalyst system. So it's like the AdBlue catalyst, that it's very sensitive to things like sulfur and phosphorus. But its job is to take that carbon monoxide, convert it to carbon dioxide. Although it's a greenhouse gas, it's a nicer gas than carbon monoxide. Particulate matter, which is the soot we mentioned, if it can oxidize that again, unfortunately to carbon dioxide, but it's better than particulate matter being lodged in the DPF. And hydrocarbon, which is obviously unburnt fuel, so we will again get water vapor and carbon dioxide out of that. So it has a go at scrubbing the exhaust gases before the other two systems have a chance. So it's saving them a little bit of effort, if you like. So all of these things, all of these lovely after treatment devices and IAgrE, they've imposed certain restrictions upon the engine lubricant specifications. As I say, we want to look after the engine, we want to maximize its service life and the component life, but we don't want to reduce the life of the after treatment devices. So it's a balancing act. There's a proper balancing act here. There are two major global classification systems that we follow, and all of the original equipment manufacturers also follow. We have the European classification system, which is abbreviated to IAgrE. Particularly, this is a committee of all the major OEM engine builders in Europe, specifying what they believe should be a minimum quality or performance level for an engine oil going into their engines. We can see here we've got in front of us the IAgrE specifications of E7, E4, E8, and E11. They've all been around a little while. They all evolve as emissions legislation changes to be more controlled in terms of their chemistry and their makeup. But this market particularly enjoys IAgrE 11. So IAgrE 11 will appear, previously E9 till a few years ago, will appear on a lot of off-highway engine oil lubricants. It's particularly favoured because it has very good soot control capability. And because we are in a world where there can be a lot of idling as well as reasonable, possibly road speeds now, of course, decent road speeds, but it's the idling which tends to create a lot of soot and excessive soot because the combustion process isn't as efficient. And because of that, this kind of a duty cycle creates an excessive amount of soot. And E11 has been formulated to provide additional levels of dispersancy and wear protection. So you'll always see that tucked away on a data sheet or a product, engine lubricant designed around off-highway equipment, such as obviously the ag market. That's the Europeans. The API, American Petroleum Institute, which is a North American body, runs a kind of a parallel system, if you like. And obviously they'll have North American built engines like John Deere's, etc. Whereas obviously, you know, from the IAgrE, the European side of things, we'll have Deutz, we'll have AGCO Power, previously Sisu and MAN engines even these days as well. But for the North American builds, then we have the API classification system. This gives you more of a flavour in terms of the capabilities. It's less complex than IAgrE in some ways, but you can see the evolution. There's some really older API specs than this, go back to the kind of 30s and 40s, back in the classic and vintage days. But currently, API CI4 and CK4 tend to be the go-tos for this market. The difference between a CI4, really, well, CI4 will not do DPFs. These are particular filters. There's too many goodies in there, as the Americans would say, too much chemistry in a CI4. So that would block a DPF. It's safe with AdBlue catalyst, but would block a DPF. And as we've kind of progressed through the years, as you can see here, API CJ4 has pretty much disappeared now, but we've started to see the engine modifications and exhaust system modifications introduced in order to comply with emissions legislation. So API CK4 is really where this market sits now. So we've got IAgrE capability, we've got AdBlue catalyst capability, DPF capability, diesel oxidation catalyst. But also more importantly now, and this is really getting introduced into nearly every classification system in terms of engine lubricants, is its biofuel compatibility. So biofuels are getting introduced at a higher and higher rate all the time. And biofuel, which is, yeah, it's correct, we should be using biofuel, but it does have its side effects. It can accumulate in the sump, it can dilute the engine lubricant, it can create lacquers and gums and resins, which can affect engine operation and efficiency. So as we move down to API CK4, We've now got something which is capable of looking after all these after treatment devices, but also provides good levels of biofuel compatibility should any of it get down into the sump. So these are the important classifications, the ASEA and the API classifications. As I say, things like ASEA 11 are important, API CK4 are important. And the OEMs, just a quick mention before I go through the slide, they tend to take, if you're a European builder, you'll take the ASEA classification system and add into that all your own requirements, whether it's better soot control, better cleanliness, better elastomer compatibility, better turbocharger protection. They will add their own whistles and bells on. Same with API CK4. If you're somebody like John Deere, for example, you would add your own whistles and bells on there. So those two classification systems are important because they form the basis for all the OEM specifications as well, which enter the market. So this is a bit of a doom and gloom slide, but it's a case of, we hear lots of horror stories. So we've been doing this a few years now, and people tend to look at what's the cheapest product they can afford to buy. But cheap normally means poor performance. And if you are putting into that engine, in these days, a stage 5 engine is extremely, I call it Swiss timepiece in the way it operates. They're very, very much precision built now. But if you do put an incorrect lubricant, which is not recommended by the manufacturer, then these are some of the disasters you can, I wouldn't say enjoy, that's probably the last word you'd use. Block DPFs, I've already mentioned the cost of a DPF to replace can be in the tens of thousands. AdBlue catalysts, again, thousands of pounds. Diesel oxidation catalysts, thousands of pounds. If you haven't got the wear control, you will get accelerated and premature failure of engine components. They will wear out prematurely. Poor soot thickening control, who I've already mentioned, you can lead to overheating, poor cooling, and because a lot of this equipment tends to get used mainly when the weather's well and good and we've got decent ambient temperatures, but also may be sat there without any airflow over the radiator, overheating can be catastrophic, as can oil starvation if you're not dispersing that soot effectively and allowing the oil to circulate correctly. We saw in the past soot compaction can be a problem. Certain manufacturers introduced IAgrE without understanding the impact of excessive soot. Excessive soot started to build up behind the compression rings and compacting and pushing the compression rings out, which basically effectively starts to not only remove the edge of the compression ring, but starts to remove the honing marks on the liner as well. And without the honing marks, of course, there's nothing for the oil to hold on to. So you start to get oil consumption issues, you start to get poor compression, reduced power. And if you've got any after treatment devices in the system, all this oil getting down there is not going to do them any good either. So soot compaction can also be an issue. And I talked about corrosion control, particularly with IAgrE. So if you're not protecting those parts of the engines, the sort of valve guides, valve stems, then you can start to get fuel efficiency problems and engine efficiency problems as well. And usually when you've got poor combustion control and combustion efficiency, then the emissions aren't particularly good. So this is the doom and gloom slide, but as I say, which is why it's important to make sure you're selecting the correct lubricant for that particular engine. So we'll move through the components now. So our compartments rather. So we're looking at transmissions. Okay, so transmissions, I suppose, are an area again where we've seen a lot of evolution in terms of hardware, particularly where we're looking at more sort of autonomous control. There's a lot more computer control now with GPS mapping, etc. You leave it to go up and down the field on its own these days. So that requires computer control of the engine, of the transmission system. So there is a lot more sophistication around transmissions than used to be, rather than the old sort of like crash boxes going way back. We've got all sorts of different designs now in terms of transmission, from the sort of power shift, sort of automatic transmissions to continuously variable transmissions, the CVTs, which use variable displacement pumps to give you a whole range of infinite gear ratios. There's a lot of complexity now in these gearboxes, these transmissions. So the fluid has got to do a variety of things. These are what I would call the basic requirements for any good transmission fluid. Something we call shear stability, which is effectively the ability of the oil to withstand being thrashed between gear sets or gear teeth. That thrashing effect, that shearing effect, can reduce the viscosity of the oil. And obviously viscosity, thickness of the oil is important, particularly when we talk about bearing lubrication. So shear stability is the ability for the oil to take that mechanical thrashing and still hold its body, for want of a better term. Low temperature performance important, as is with any lubricant really, and particularly where you may be operating equipment in exposed environments. You know, low temperature, the ability to operate and flow when the unit is cold is important to get that lubricating oil film round to all the critical components. Is essential to protect those components on the cold start part of its operation. Also, you know, I always say, you know, basically your transmission there is it's transferring energy from the engine to do a job of work. So whether that's the wheels, whether it's to any ancillary equipment on the back, the hydraulic pump, which we'll talk about. You know, where you have energy, you have heat. And where you have clutch materials and clutch packs, certainly in a lot of these transmissions now, you generate heat. And if you don't want that particular part of the transmission to overheat and cause damage and problems and reduced efficiencies, then you need to take the heat away. So, you know, one main job of the transmission fluid is to take away any excess heat and keep it at an optimum running temperature. Where you have friction plates and materials and engaging and disengaging, you will get debris from that. It's microscopic. But if you want positive engagement, you have to keep those engaging surfaces nice and clean. So the job of the lubricant is to flush these surfaces continually to make sure you have positive engagement and not sticking, slipping effects, which can generate even more debris and reduce component life. Balanced friction, going back to our clutch packs, etc., and friction materials. If you want positive engagement, you don't want slipping to take place. So we need to make sure we're able to modify that friction in order to be effective and give you positive control. Anti-wear protection, you know, there's lots of metal bits and bobs still in here, whether it's gear sets, whether it's, you know, bearings, etc., whether you've got shafts with sliding components on them. You want to protect from wear. So we add anti-wear chemistry. We can also add extreme pressure chemistry. So think of EP chemistry, and if anybody smells an old traditional gear oil, it's the sulfury smell you've got. EP protection is kind of the big brother of anti-wear protection. They're both in there to provide a sacrificial chemical boundary between metal surfaces which may be meshing or mating together. So rather than getting metal to metal contact, you've got chemical to chemical contact. So they're sacrificial in some way. But importantly, and bizarrely even more so these days, is electronic sensor compatibility. So, as I say, because of more autonomous kind of operating abilities, and certainly this is the area that not this industry, but all industries are going into. There's sensors everywhere, and it's important where you're looking at lubricants that they are compatible with the sensor materials. I mean, there's obviously a lot of copper in sensors. And the last thing you want is a lubricant which is going to start corroding the copper, because then you will not only get spurious results, but even when you put a laptop on there, you'll start to see things which aren't quite right. So you want positive, sensible, accurate information from these sensors. So ensuring that the lubricant is sensor compatible is a big part of formulating these days. So if we get it right, we've got lots of nice smooth engagement of the clutch or brake bands if it's an automatic transmission. But any engagement of clutches will be nice and positive and smooth. A comment here really, which applies to all these things, you've got to make sure it's going to meet your service interval. There's no point formulating a lubricant which will get to 500 hours, but you're going to leave it in for 750 hours because you've got 250 hours of unprotected use. So you need to make sure there's enough goodies packed away in here as well to last the longest of potential service intervals. Of course, you're going to maximize component life. That's what we want. And this is certainly a market where performance tends to trump price, because when it's busy, when it's active, when you've got a weather window that you've got to operate within, you want to be able to jump into that vehicle and use it straight away with confidence. You don't want it ending up in a workshop when the heat is on, as it were. So, and you want to maximize that component life, and you want to give it as much robustness as you possibly can. And of course, I'm just mentioned reduced downtime already, but reduced downtime in this market is an important feature of getting it right. But if we get it wrong, okay, the doom and gloom. Okay, so under load, particularly, and I say, you're transferring power energy from the engine to do a job of work, then things will slip and slide. You're not getting good efficiency. You're reducing your fuel efficiency, as well as you're getting energy losses, which aren't particularly good. If you've got hydrostatic drives, okay, so if you're using hydraulic power to drive hydraulic motors at wheels or tracks, then if you don't get an oil which is kind of shear stable, if it can't put up with the thrashing it gets as it goes through the pump or the control valves, it will thin down. And if that oil thins down too much, the volumetric efficiency of the pumps which drive the wheels or tracks will decrease, and you will lose drive effectively. There's nothing for the pump to push against. So if you formulate that incorrectly with really poor shear stability, then that will be a problem. Bearing wear, okay, all of these rotational mechanisms have got bearings on them somewhere. So you're lubricating bearings, but if you haven't got enough thickness to the oil, viscosity in the oil, or you haven't got enough wear protection, then bearings will suffer. Shifting gear mechanisms, they're carrying all the load, okay, and it could be pinpoints on gear teeth, which is carrying a hell of a lot of load. You want to make sure that you're reducing any wear, because shifting gear mechanisms are, again, it's a lot of downtime to replace them. Overheating, I've mentioned this already. If that oil is too thick, or it oxidizes and thickens because of too much heat, if you're relying on it as a hydraulic medium in, say, an automatic transmission of some description, then you're not going to get effective cooling. And of course, as I say, degradation of electronic sensors. If that chemistry is unbalanced, you will start to get erroneous results popping up on the dashboard and with laptops as well. Okay, so hydraulic pump, we've touched on that already. In any system, any hydraulic system, it's the pump which is basically the heart of that, and that tends to be the most expensive part that you need to lubricate and protect. There are a variety of different pump types used in this market. The variable displacement piston pump that you can see there, and that moving graphic, is very much now quite prominent in the continuously variable transmission systems which are on the market. But it could be just something as simple as a rotary vane pump, for example, as well, which is also shown. But whatever the design happens to be, you've got a multi-metal system. Okay, so most of these builds may be just steel on steel, but in terms of the variable displacement piston pumps, you will have things like copper shoes, various other things, or copper alloys. So you have yellow metals in there as well. So not only do you need to protect the steel from wearing out, whatever you're using to protect the steel shouldn't attack the copper. So you've got that balancing act of steel protection without corrosively attacking any copper alloys which may be in the system. When the pressure's on, when you've got a good high throughput, and especially if these pumps are used in actually driving the vehicle, it needs to be able to withstand extreme pressures. When the pressures get ramped up, Cavitation can be an issue with hydraulic pumps, which can cause not only damage to the pump itself, because unfortunately air or foam isn't a very good lubricant. And if you've got that going around a hydraulic system, not only do you get poor lubrication, which leads to excessive wear, but you'll also get spongy operation, especially if it's a piece of ancillary equipment run from fluid couplings off the back. But again, if you've got these variable displacement piston pumps, which are providing drive to wheels, etc., again, that's going to affect the ability for it to drive those wheels. So controlling foam is an important feature, and foam is kind of a no-no in any mechanical system. It doesn't matter, we're talking about hydraulics now, but if it was the transmissions or the engine or anywhere else on any vehicle, foam needs to be controlled. So sometimes we will add the necessary chemistry to control foaming. Seal compatibility, important. Again, although it's just mentioned with the hydraulics here, certainly in terms of anywhere where you've got elastomers or seal compounds, which tend to be fairly kind of sort of standardized in most industries like this. Thankfully, you don't get anything too exotic. But you still need to make sure that any lubricant that's in there is not going to either shrink that seal material or cause it to swell, because either option isn't good, because you'll lose the oil or you'll let the environment in, which can be even worse. And water ingress is important. Water in any system that gets hot and cools down again, most of these systems will have breathers on them. You can draw in air. If there's moisture in that air, the moisture will condense, and water can potentially degrade chemistry which is contained in the lubricant. So you need to build in a robustness to the chemistry that you use to ensure that it's tolerant of a certain level of water ingress. I mean, the reality is, of course, some of these vehicles could be used in countries where there's high humidity. So just air, it's got a lot of water in it as well without condensation. So you need to manage the water ingress. Well, get it correct, then you're protecting the heart of the system, the pump. You're looking after the control valves and spools and things. You're looking after the components, getting maximum life out of there. And of course, importantly, you're getting efficient operation. Doom and gloom slide. Okay, so what happens if we get it wrong, if an incorrect lubricant choice is made? Well, the biggest failure is going to be the pump. The pump's going to be the big issue. One of the contaminants, which I didn't mention on the previous slide, is actually the majority of pump failures are down to abrasive wear through particulate matter, dirt, effectively being in the lubricant. And there have been cases where we've seen oil supplied from a manufacturing site which are dirtier than oils which come out after a service interval. So that is introducing particulate matter which is going to be abrasive and give excessive component. So if you haven't got enough wear protection, you'll get excessive component wear. If the cleanliness of the fluid going in there isn't good enough, you'll start to get excessive component wear. Certainly here we will filter down to 5 microns before it goes into container. So it's pretty clean oil that's going to be introduced into a system. Foaming, as I mentioned, leads to spongy control, which could be dangerous as well. It depends what you're controlling with that hydraulic system. But air is not a good lubricant, so that'll start to give you accelerated wear issues. If it's no good at high temperatures or pressures, then the hydraulic oil effectively loses its body. It thins down too much, and again, you'll start to get cavitation, and we know that can be dangerous as well. Poor tolerance will lead to the ineffectiveness of the chemistry that's in there. The worst case scenario is, and I always remember as a child, the old sort of snow globe at Christmas. You shake it up and you get a little snow scene with Santa in there and various other things. Effectively, what can happen to poorly formulated hydraulic fluids or fluid designed for hydraulic systems is we call it a flock. So the actual chemistry comes out as a flock, which is like a solid matter, which the filter will take out, because obviously there'll be a filter in the hydraulic system, and you then end up just taking out all the chemical protection that you've got in there. So that's not a particularly good side effect. I mentioned unfiltered hydraulic oil already. I must have got excited about that point. As I say, you can start to see accelerated wear straight from day one when you start to put it in there. If you haven't got the correct formulation in there with the correct chemistry, you will start to see things like gumming, which tends to happen at high temperatures, sludging, which is a bit cooler, but it's to do with water and debris, controlling that properly. Varnishes also tend to be kind of high temperature, but any of these things will impact upon the manufacturing tolerances of the equipment. You know, you're starting to build layers upon things which weren't there when the componentry was new. So that is going to start to reduce operational efficiency. So these are some of the disasters that can potentially happen if an incorrect lubricant is chosen. PTO, so our friend the PTO. So obviously we've got various ways we can take power from the back end of a tractor. Obviously we've got there you can see the fixed PTO, which is obviously a direct coupling. But more and more these days, of course, we've got fluid couplings, whether that's for operating rams on trailers, whether you've got a piece of ancillary equipment on the back, which has got its own, you know, you've got an issue with pieces of equipment being shared around various agricultural tractors. They could be laid up for a little while before they're used again. So any residual oil left in that system must be able to protect those components from corrosion. Fluid compatibility is important. There have been many cases over the years where tractor manufacturers have tried to warrant the actual fluid. I won't mention names, but when you've got a working farm with a variety of different tractor makes and models and a variety of different ancillary pieces of kit, they get swapped and changed around. And if you've got fluid couplings, of course, you cannot ensure the integrity of the fluid that was in the back end is going to remain the same once you've shared it around to other different bits of kit. So you need to make sure that whatever chemistry that we use isn't bizarre, weird and wonderful stuff which could cause issues if mixed with other fluids of this type. And I've mentioned compatible with hydraulic systems, as I say, particularly important if you've got ancillary equipment which may have its own built-in hydrostatic drives. But you know, so the benefits: good foam control means positive use of the fluid couplings, and also the PTO, because although it's a solid PTO, fixed PTO rather, you do have obviously a clutch pack behind there, so you want to make sure you're getting positive engagement, and you also want good fluid stability as well. As I say, you know, when you've got fluid coupling, you're shearing the oil through the hose to the piece of ancillary equipment. It's getting sheared through its own high hydrostatic system potentially. So, you know, if you've got it right, nothing will suffer from poor drive performance. But doom and gloom, get it wrong. Okay, as I say, if you've got a fixed PTO, you will have a clutch pack at the back of there. So
sorry to interrupt, Adrian, but your slides have dropped off sharing.
Now what? Sorry, they've dropped out.
Yeah.
Do you want me to
reshare? Yeah. Thanks.
Share. Okay, let me get back to share.
I think the signal just dropped out momentarily, so I think it stopped sharing.
That's fine. Okay. Yeah. So if you've got, you know, as I say, if you've got a fixed PTO with a clutch pack at the back of there, you want positive engagement. You don't want slipping and sliding. So, but that will happen. And of course, if you've got friction material which is sliding and unnecessarily, it just increases wear, which is not particularly what anybody wants. Poor hydraulic actuation, as I say, if you've got fluid couplings which are relying on a good sustained hydraulic pressure, that won't be achieved. Getting excessive foaming, as I say, you know, and it could, as I say, this could be a safety issue here, especially if you've got rams which are doing a particular job near personnel or various other people. You want predictable performance out of hydraulic rams, which may not be the case if you've got lots of excessive foaming going on in the system. Okay, so oil immersed brakes, my favorite subject. These are very useful for policing the quality of lubrication going into an oil immersed brake system. They police it themselves, normally by noise. Obviously with an oil immersed brake system, the actual braking mechanism is in its very own oil bath, its oil chamber, if you like. And obviously in the off-highway world, where there's a lot of airborne debris and abrasive material, an air ventilated disc brake on a car, for example, would not survive 2 minutes in a freshly ploughed field. So the whole point of all immersed or wet brakes is it's basically cocooned in its own little protective environment. But of course, being a braking system, and going back to the fact we are generating energy to do a job of work, when we apply the oil immersed brakes, then heat will be generated because you're dissipating a lot of that energy through frictional heat. But again, it's all about keeping everything in a controlled operational temperature window, if you like. So, so one of the big jobs of an oil immersed brake system or wet brake system oil is to control that temperature when the brakes are applied. These obviously have got clutch packs in there. So the clutch packs, again, you want positive engagement. You want to protect from too much wear and this slipping and sliding, known as squawk and chatter when we come to oil immersed brake systems. Not only vibrational issues it causes, which can cause bearing wear, but also, if you are generating, if you're not engaging positively, you generate excessive amount of wear from these clutch packs, these clutch materials. You've got gears in there, and of course you may well have pumps as well, depending on the system involved. So you need to look after all those different components. Good water tolerance. I've already mentioned water tolerance when it comes to hydraulics, but the oil immersed brake systems, the chemistry used in oil immersed brake systems is very sensitive to water contamination, and it doesn't take long for the actual ability of the chemistry to protect from this thing called squawk and chatter, particularly. And the way this kind of works in terms of controlling the friction, it's right down at the molecular level. So we can control coefficients of friction right down to the last minute. So just at the point where those clutch packs may be about to slip and slide because friction isn't great enough, friction modifiers, which are molecules that we literally put into the lubricant, kind of grab on, if you like, and artificially increase the coefficient of friction just before sliding takes place. So that can prevent the squawk and chatter, which is basically that slippage. So get it right. You've got, again, the oil will last through the service life, which is what's important. And any friction material in there, any clutch packs, etc., will enjoy maximum service life. Get it wrong, I've mentioned it several times, squawk and chatter. It's which is why, as I say, it kind of polices itself, these systems do, because if you haven't got the correct chemistry, you can hear it even though you can't see it. Premature wear, we don't want that. Again, like, the ag market is particularly sensitive to downtime when you don't want it. So, taking away the nervousness of premature failure is an important job of the correct lubricant. So we don't want friction plates, and friction plates particularly now, certainly in all immersed brake systems, where we've seen increased road speeds. We've got 55k boxes, I think, quite possible these days, even more possibly, where you are traveling at a reasonable speed down on the road, and you may be pulling a trailer as well. You need to be able to safely stop a heavy vehicle without causing any accidents or issues. So these all immersed brake systems are even more reliant on the correct lubricants going in there, because it's a massive safety feature for now, as I say, for these higher road speeds. So the last thing you want is for the clutch pack system to pack up on you when you're in an emergency braking environment. Vibration from the squawk and chatter will eventually to bearing wear, which again is a catastrophic downward cycle. And I've already mentioned the safety issues, braking from speed, under load. It's got to be effective, and an incorrectly formulated or immersed brake oil will not give you braking confidence, which is not a good thing. Okay, we also have simple things on our vehicle. We have simple gears, things like reduction hubs, for example, which are a nice kind of, a planetary gear set. Nothing fancy, nice straight cut spur gears, doing a job of reducing the power to a workable level for the wheels, so you don't wheel spin everywhere all the time. So you've got some nice standard gear systems in there as well. So like any standard gear system, you want good extreme pressure protection. So where you've got meshing gears, you will obviously you're carrying all the power through a couple of small areas of these meshing gear teeth. You create a lot of temperature and pressure there, and EP protection. The sulfur I mentioned earlier, you can smell the sulfur. Sulfur plates out under those high temperatures and pressures to give you a sacrificial chemical film rather than the gear teeth meshing and wearing themselves out. If you have, and most tractors now will have limited slip differentials, particularly on the front axle. You need limited slip differential performance in terms of shock loading, because whilst everything's happy and you're getting even power distribution to the drive wheels, as soon as one of those starts to slip, of course, you get drive preferentially moved to the spinning wheel with the less with the less friction. Okay, so it's the line of least resistance. So that spinning wheel obviously reduces any forward motion, and the other wheel will just be sat stationary. So limited slip differential, of course, detects that. There's various ways of doing it. Back in the past, you could put a manual diff lock on and do it, but you've got electronic means now of engaging the limited slip differential, or mechanical means, which tend to operate in centrifugally, and they will engage. But when they engage, there's a lot of shock loading, because you're going from all the power going to one drive wheel to suddenly being redistributed 50-50 to both drive wheels. So you need excessive extreme pressure protection in order to look after all those components, which are for a short space of time under a very high shock load environment. Good thermal stability. So this is the ability of the oil itself to cope with high temperatures. When it all becomes oxidized, I always think of it like I used an old chip pan, if you like, which hasn't been cleaned out regularly. The carbonaceous deposits you see in an old chip pan are basically oxidized lubricant, which isn't good. It's not an effective lubricant anymore. So anywhere where temperatures for a prolonged period of time may be experienced, you want the oil itself to look after itself in some ways, and good thermal stability is important. And again, going back to these high road speeds again, it's operating like a truck axle or even a car axle, if you want to think of it in those terms. So you may well get good heat soak on these axles, depending on how long they've been driven for and what the ambient temperatures are like. Friction control is important certainly for the limited slip differentials, where you will most likely have a clutch pack of some description. So that's important. You don't want that slipping. Again, you want positive engagement of the differential. And you've got lots of gear mechanisms in there, as I say, some straight cut teeth. You've got a differential itself, which may be a crown and pinion kind of design, but you'll certainly have the kind of planetary gear sets and the reduction hubs as well. So you want to look after all those surfaces, all those steel to steel kind of environments, and the bearings, of course. Get it right, you can extend the life of those components and that equipment. If we get it wrong, of course, I mean, the biggest issue with gears is excessive in terms of getting it to do a job of work. And as I say, particularly now with these higher road speeds and potentially higher loads, the propensity to wear out quicker is a danger. So you need to make sure you've got a correct level of EP protection in there. Bearing wear, as I say, I keep going back to bearings. They're always in there. They've got to be looked after, depending on what the operating conditions are. But They've got to be looked after under the worst operating conditions, if you like, the most challenging operating conditions. Where you've got heaters, to say you've got these lacquers, these high temperature varnishes, these kind of things, which can impede shift quality if they're building up on the gear sets, on the gear teeth. And as I've mentioned already, excessive oil thickening, that will lead to poor cooling and overheating and overall reduced efficiency. But potentially in the worst case scenarios, it can be also catastrophic as well. Okay, so those are the main components or compartments, basically. Those are the main jobs of the main fluids. A lot of this market, it's a balance of what I would call multi-purpose products. Tractor transmissionals, for example, can be used in obviously transmissions, oil immersed brake systems, hydraulic pumps, PTOs. They can be multifunctional. Some manufacturers will split off the hydraulic circuit and have a separate hydraulic coil. Engines now are pretty much separate. Back in the day, we used to have super universal tractor oils, which did engines and back ends. But with the advent of emissions control legislation, all those lovely goodies and chemistry that we've been talking about for the last couple of slides, well, half a dozen slides or so, they will impact on after treatment device performance. So certainly we're in the world now of what I would describe as engine oil and back end oil. These are two very distinct product lines. Super universal tractor oils are still available, and some people, as I say, there'll always be an older piece of equipment lying around somewhere where those could be a commercially viable alternative. But certainly, and as a company, we work with major OEMs. We've certainly got millions of sort of operating hours, if you like, under our belt to know that if you're formulating correctly, you're ticking the boxes, you're making sure the OEM specifications are satisfied, you're going to optimize equipment life and performance. And as I say, this is a market where it's a B2B market, certainly for companies like us, where you want to make sure that the farmer has the most reliable piece of equipment he can do when it's the busiest of periods. And formulating it correctly and ticking all the correct boxes is the way of ensuring that. I say the OEMs, they have their own their own exacting performance standards and demands. They expect a lot. They look at everything from cold temperature to high temperature performance, elastomer compatibility, gear wear, you name it, shifting ability, oil immersed brake performance. It's quite a plethora, a big matrix of different requirements. But it's about ticking the boxes, making sure you're meeting all their requirements and their demands. Particularly, of course, if a vehicle's under warranty, that's an important feature. If an approval is required or a vehicle is under warranty, you need to be able to prove that the correct lubricant has been supplied under that particular set of situations. Importantly, again, in this market, the maintenance interval tends to be very strictly adhered to, more than perhaps the on-highway market. But there is also a certain level of safety margin built in. If it's 750 hours, it'll get to 751 and the oil fails. There's always a little bit of wriggle room at the end there, because obviously it could be in the process of gathering the harvest and you come up to your service interval. There's always a bit of wriggle room. So despite the fact, we're ticking all the boxes and we're making sure that we're complying, we always add a bit of safety margin as well, just in case that particular scenario comes up. Again, I suppose, it's for a farmer who's got a business, who's relying on the equipment, it's going to have a massive impact on his operating costs. Improvement in his operating costs, particularly if he hasn't got expensive downtime, where he's then got to hire a piece of equipment to carry on, especially if you've got a very tight weather window to operate within. They're increasing the equipment life. As I say, people are hanging on to the equipment for longer now, so they are caring for their equipment much better than perhaps they did when they were turning vehicles around every 3 or 4 years possibly. We see a very mixed spread now on most farming community sites, where you've got a mixed bag of 1980s, 1990s vehicles still being used alongside all the modern Tier 5 compliant models that we're talking about. Mention warranty, yeah, we don't want warranty issues, so it's about formulating it correctly so there can be no problems. Going forward is concerned, we're certainly seeing we can only see further complexity to a certain extent, and I think a lot of this will be driven by autonomous vehicle operation, where you're getting a lot more electronic control, certainly on the transmission systems, and so there will be an element of increased complexity. But again, as this equipment evolves, we also need to make sure that the us as lubricant providers are going to shadow that trend and make sure that we're providing the correct lubrication for all the right reasons that we've spoken about today. So I think that basically covers the just in case, sorry, bless him. So anybody doesn't know Guy Martin, if you wanted any more in-depth information on agricultural lubricant applications, then you go onto the Morris Lubricants website. We do have a series of training videos that cover all the compartments I've spoken about today. They're not long, particularly. A coffee and a packet of hobnobs will probably get you through them, but that will give you the opportunity to, again, perhaps review some of this if it's of interest to you. But as I say, these are kind of a little box set of videos that we did a few years ago now. But the principles never really change that much. So just to guide you to that, if you'd like a little bit more background on what I've done today. Otherwise, I think we're over to questions, I think. If there's any questions, and hopefully that's been useful.
Sorry, I won't open the floor up to questions, Adrian, because we are a bit over the hour. So thank you very much, Adrian, for the excellent presentation and taking time out to do it. It is very much appreciated, and I'm sure people have found it interesting, and those that need any further guidance will be in touch. So thank you for everybody for joining us today. I hope you'll join us for the next lecture on the 11th of November, where we'll be joined by Mike Wooding and Tim Pearson, who'll be speaking about crop mapping using satellite data.
Autonomous control.
I'd also like to remind people that our annual conference is next week on the 22nd of October. It is online, and we'll be looking at artificial intelligence in agriculture. We've got some brilliant speakers lined up from industry, including AGCO and Class, and some leading academics as well. So please get yourself registered.